So I'm going to do a quick example on calculating the standard deviation. We're going to use this example on metabolic rate. They took 7 men who were taking part in this study, and they calculated their calories per 24 hours, and they got these 7 values. It says enter these into your calculator or software and verify that the sample mean is 1600 calories and the sample standard deviation is 189 calories. So how did I know this is sample? So X bar and S means sample. S is sample standard deviation. If you had sigma here, sigma or mu for the population mean, sigma for the population standard deviation. That's important to know because you don't always know whether or not to use the n-1 or divide by n in the standard deviation formula. So in this case it's very apparent because we have a small sample of 7 men out of all men, so this is obviously a sample, and then we can look again here that it's S. So we know to divide by n-1. So if you watch my other standard deviation video, the first thing we need to do is calculate the mean of these numbers. So to calculate the mean, we're going to add them all together. $14.60 plus $18.67 and divide by the 7 values. So our mean is 1600, and that checks out for me because I can look over here at our data and see that 1600 does look like it falls within the data. If I left one out, this would be off quite a bit. So it's always good to check. So our mean is a nice easy 1600. It checks here, 1600. So we've got that correct. So the next step in calculating standard deviation is to subtract the mean that we just calculated from each individual value, and that'll give us the distance from the mean that each value is. And this first number here, 1792, let's see, we're going to take 1792 and we subtract the mean of 1600. That button doesn't work. That'll give us how far away from the mean that first value is. It's going to give us a positive number because it's above the mean. When we do 1362 minus 1600, that's going to give us a negative number. When we add all those up, it's going to give us 0. So the first thing we do is square these values before we add them. So I have value number 1, 1792, minus the mean squared. And I'm going to add that to value number 2, which is 1666, minus the mean of 1600 squared. Add that to the next value, which is 1362, minus 1600, again square it, add that to 1614, and that value is right close to the mean there. So standard deviation is talking about spread, right? So if all of our values are very close to the mean, like 1614 here, we're going to have a much smaller number than if we have values that are further away, like 1792, right? That's 192 calories away from the mean, right? So when we do this calculation where we're adding up all these numbers, if the values vary largely, we have a higher standard deviation than if the values vary lightly or small. So the smallest standard deviation you can have is 0, and that occurs when all your numbers are exactly the same. So the next number here is 1460. Oops. Let's see if I can figure this out. 1460 minus the mean squared. How many more values? a couple more values here. 1867 minus the mean squared. And finally, we have our last value here, 1439 minus 1600 squared. So enter. We've got a very large value here, right? We can take the average of this now. So we added up all of our deviations from the mean here, right? So we're basically taking an average of how far each value is away from the mean, right? So we're adding up each value's distance from the mean, right? That's what each of these little parentheses is how far away from the mean that value 1792 was. We add up all those deviations from the mean and divide it by n minus 1, how many values there were minus 1. So I'm going to divide here by 6, and 35,811 should be our variance, right? The issue here with variance is that it's in calories squared, right? We squared all of these values here. Each one of these was squared, so our units were squared. So now we have to take the standard deviation. To get the standard deviation, we have to take the square root of this 35,811.6667, and that should give us the number we're looking for, 189.24, and if we round up, it does. So we take the square root. That's how we end up with the final value there for the standard deviation. Hope that helps out.